Hey everybody, this is just me going over all the test questions for you. So hopefully you can understand why you missed the ones you missed, and if you are willing to do the retake, you get it right this time. Okay, so let's get started. First off, you're always putting your name on this, right? Let's go with Jane Student this time instead of Joe Student. This is his twin sister. I always put the date on there. And I think you guys took this way back before break. Okay. All right, so identify the terms, coefficients, and constants. There's three things we need to identify. Some of you only identify two. This is just vocabulary. Right? You can learn someone's name. You can learn the name of parts of an equation or an expression. Okay? I think most everybody knows that that x there is the variable. Let's go ahead and zoom in a little bit, make it a little tighter for you. And that 17, most of you are starting to learn, that's called a constant, right? The 17 is always worth 17. So I'm putting the 17 by the constant. I'm going to circle that. The terms, each part of the equation that's separated by an addition or subtraction sign is going to be a term. So that 4x is a term, and the 17 is a term. Okay, and the coefficient is the one that most kids get a little confused about. It's the number, the way I describe it, it's the number that's stuck to the variable. Okay, you're multiplying or dividing it. Okay, so the 4 is the coefficient. If I had just an x, like if it was 4x plus 17 plus x, the coefficient for that x by itself would be a 1. Okay. In this case, the 4 is the coefficient. All you had to do is identify those three, and you got 3 points. The expression 2 times r times r times r times r, right? I think at this point, if you had a problem and it said like 3 plus 3 plus 3 plus 3 plus 3, you'd feel silly writing it like that. You'd write 3 times 4 or 3 times 5, depending on how many times I said it. So in this case, we're using exponents. This is the same as 2 times. This whole thing is r times itself 4 times. So 2 times r to the 4th power, and you don't even need that times sign anymore. But this is the r to the 4th power. There are not 4 2's getting multiplied together there, so it's not 2 to the 4th power. Some people were confused about that. This, I think these should be simple. I always say you get to play Ted Lasso, play soccer coach, and all you're doing here is substituting. Okay? And most of you figured that out, but some of you made the most common mistake, right? The most common mistake when you do an exponent is think that this is 6 times 2 is 12. It's not. It's 6 times itself 2 times. So 6 times 6 is 36. And then 36 plus that one more is 37. Okay? All right, number 4, write the phrase as an expression. And I really tried to drill in with most of you guys that the most common mistakes people make when they're writing expressions is when you have a problem like this, where it says 15 less than something. Everybody wants to write 15 minus. But if you think about it, how much less is this expression? It's 15 less. I'm subtracting 15 from something. What am I subtracting 15 from? From the n. So this is n minus 15. You got to get that down because you know, like this, right? When we identify and talk about the most likely mistake, most popular mistakes, most popular wrong answers, those are often ones that are going to be choices on tests. They want to make sure that you aren't making that common mistake. Okay? So let's get that one down. Simplify the expression. That means I'm just going to write it simpler if I can. Okay, and in this case, I have the 12 plus x in parentheses. Associative property, I can regroup things I'm adding or multiplying. Associative property of addition allows me to say, you know what, this is the same as 10 plus 12, and have that x all by himself. 10 plus 12 is 22. 22 plus x is my answer. I can't combine the 22 and the x. Those are apples and oranges. Remember, when we combine like terms, same variable, same power. And then you can combine all the constants. As long as they're not stuck to a variable, right? Constants are not coefficients. All right, number 6. Tell which property, the statement. I went through a big deal showing you how I used to commute from Roder Park, right? Which was further, driving to work or home from work? It's the same. 1.8 plus Q is the same as Q plus 1.8. And when we've done diamonds, I almost always say, what if someone did 6 times 7 and 7 times 6? It's the same, Mr. Daniel. Right. So, same thing frontwards as backwards. The commute is the same to work as getting home from work, and this is called the commutative property. I'm not sure why that is so important to the people that make tests, but it is, and it's not that big a deal, right? Because this isn't a tough thing we have to figure out. This is a vocabulary word we have to memorize. And you can remember teachers' names and friends' names. You can remember the name of that property, okay? Commutative property of addition. If I was multiplying, 6 times 7 equals 7 times 6, I would say that's the commutative property of multiplication, right? Remember, addition and multiplication are commutative, subtracting and dividing are not, okay? Let's scoot this up a little bit, get to number 7. We got a little bit more room. Number 7, use the distributive property. Distributive property, remember, we talk about dealing cards. You distribute. You're playing Uno. Everybody in the game gets the same number of cards. The outside number is the dealer. That 3 parentheses means 3 times that parentheses. But it's not just 3 times the 9x. It's also 3 times the 1. So I have 3 times 9x minus 3 times 1. 3 times 9 is 27, so this is 27 minus 3. Okay? Distribute to each thing inside. Simplify the expression. This is combining like terms. Okay? So I have some x's here, a 5x and a plus x. How many x's are here? Well, that's 1x, right? Remember, you can always put a 1 in front of it. Just like you could always put a 1 underneath the number to make it a fraction. You could always put a decimal after a number to make it a decimal. So I have a plus 3 and a plus 4. Okay, that's going to be a plus 7. And a 5x and a plus 1x. That's 6x. That's all you got to do. Put the apples with the apples and the oranges with the oranges. All right? Factor the expression. When we factor an expression, we're using the distributive property backwards. The other thing I tell kids, it's kind of like simplifying a fraction. If I had 16x over here over 2, I'd say, whoa, 2 goes into the top and the bottom. How many times does a 2 go in the bottom? Once. How many times does 2 go into 16x? Right? We'd simplify that fraction, 8x over 1. Same thing here. 16x is the same as 2 times 8x. 2 is the same as 2 times 1. The GCF, or greatest common factor, is the biggest number that fits, F, into both. 2 fits into 16x and 2 fits into 2. You can't find a bigger number that fits into 2 than 2, right? Which brings me to a hint. Whenever you're simplifying a fraction or an expression, okay, see if the small number fits in the big number. Okay, because you can't get a bigger number than that small number in the small number. Okay, so 2 goes into both. I'm pulling a 2 out. Remember, we're going backwards from the distributive property. And that goes outside the parentheses. Inside the parentheses is that 8x plus 1. Okay, and I don't need that times sign, so I'll write it without. I wouldn't have marked you wrong if you had it, though. Okay. If I had this and I said use a distributive property to distribute, you'd say 2 times 8x plus 2 times 1, and you get back to that. Okay, so it's backwards. All right, already on the other side. What we got here? Due to gravity, an object falls 16 t squared to the second power feet in t seconds. Okay, I don't know why they made this hard problem for you, but it's kind of cool. They put some science in there. This is actually true, right? And this is in science, this is something that people get confused about, right? They think heavier things fall faster than lighter things. They actually fall at the same rate. T is the time in seconds, okay? And that's what's getting squared. That's what's getting multiplied by itself. If you drop a backpack from a window that's 20 feet above the ground, will the backpack hit the ground in 1 second? Well, I'm going to go substitute. They're telling me the second is 1. Okay, so I'm going to go to that 16, t to the second power, and I'm going to say 16 times 1 to the second power. 1 to the second power is not 2. 1 times 1 is 1. 16 times 1, 16, and this is how many feet? So if you dropped it from a window that's 20 feet tall and it only dropped 16 feet, it did not hit the ground yet. So you're saying no. And this is why. Okay, I had some kids think they were supposed to multiply the 16 times the 16. Watch those exponents. It's only going over. Now, if I wanted 16 to be multiplied by itself as well, it would be in parentheses, and that the whole thing is squared. But that's not what that problem says, huh? Okay, so no, it did not. Okay, and you can go figure out how far it would fall in 2 seconds. Because now you got 2 times 2 is 4, and 4 times 16, it falls 64 feet. Things start falling fast once they get going, right? All right, on to number 11. Car A travels. Let me do the autofocus. Make sure this is focus for you. Yeah, that looks better. Car A travels at 45 miles per hour, and car B travels at a greater speed. So B's going faster. Okay, X miles an hour. X is more than 45 because it's going faster. Write and simplify an expression that represents how many miles farther, that's a southern thing, car B travels in 2 hours. Okay, so let's just figure out 1 hour first. Okay, so car B is the X, car A is 45. The difference, since X is bigger, is each hour. This is how much farther car B is going, right? And they're saying, figure it out, write an expression that represents how many miles farther car B goes in 2 hours. So I got to multiply this whole thing times 2. Now, if you had that, it was okay. If you distributed that, it was okay. What I didn't like, you only got partial points if you just told me it's 90. Because that's not true, right? It's 2x minus 90, okay? It's pretty generous on this second page in giving partial points, right? Each problem's worth 2 points except for that first one where you had to identify 3 different things. That was worth 3, gave you points for your name and date. 33 total. Let's go on to number 12. A restaurant supplier receives a discount on each oven purchased. The original price of the oven is X dollars. The restaurant supplier purchases 5 ovens for 5x. That makes sense. The original price is X, so those ovens is 5 times X. But it says 5x minus 125. So I got to figure out how many 5s go into 125, because that's how much my discount is on each oven. The total discount is 125, but I bought 5 ovens. Okay, now they kind of wanted you to see that this is 5 times X. This is the factoring, right? And this is 5 quarters is $1.25, so this is 5 times 25, and pull that 5 out. So the price of 5 ovens is 5 times X minus 25, which means each of those ovens was discounted 25 bucks. Okay? All right. Last 3. Write an expression using exponents that represents the area of the square. The area of the square is just this times this, which is the same, right? Because it's a square. This width is the same as this height, so this is, right, area of each rectangle, length times the width, but a square is the same. So it's the side times itself. Now, how long is this line? It's not 4. It's not W, it's 4 times W. The entire thing. So, I gotta square the entire thing. You have to put it in parentheses. Now, if you decided 4W times 4W equals 16, and W times W is W to the second power, I probably gave you 2 points for it, but really they just wanted the expression for that area. This is the ideal answer, the best. The difference between two numbers is 10. Okay, so it could be like 12 minus 2. It can be 100 minus 90, right? The difference is 10. The greater number is B. Write an expression that represents the lesser number. Okay, so let's just, whenever I can't figure out what to do, I just make something easy. Let's say it was 30 and 20. The difference is that is 10, right? Now, what is the lesser number? Fact family. 20 is the same as 30 minus 10. Right? So if the number I don't know is B, sorry, I don't know two of the numbers, right? But I know the greater number is B. The greater number is going here. So I got B minus the lesser number. Let's go L with that. Make a fancy L so it doesn't look like a 1. And the difference between the big number and the smaller, lesser number is 10. That means the lesser number is B minus 10. Okay? And you can also put the lesser number first if you want to say the lesser number is the bigger number minus 10. Now, I don't know why I use B instead of G for greater. If we're saying greater than less than, and teaching that, bigger, smaller. Anyway, that's what you got there, okay? And some people just put B minus 10. I accepted that, okay? Because that's the expression. I kind of wrote an equation, didn't I? Last one. You buy bananas and strawberries in a ratio of 2 to 5. Bananas and strawberries. I'm assuming, okay, that it's the ratio. Since they said bananas first, you got 2 bananas and 5 strawberries. Write an expression that tells me how many strawberries if you bought in bananas. Well, we sort of have to figure out what is a rate here. Okay, and I want to find out the bananas. So bananas, BS is 2 to 5. Okay, so this would be 4 to 10. I have some people sort of do that pattern because it helped them, and if it helps you, go for it, right? How am I going from 2 to 5, or 4 to 10, or 6 to 15? Right? Well, what you're doing is, whoops, is 2 goes into 5. How many times? 2 times. Add that decimal and a 0, bring it down. So for every 1 banana, right, there are 2.5 strawberries. How many strawberries if you buy in bananas? Well, it's going to be in times 2.5 or 2.5 in, right? I had some kids, right, leave that fraction, okay? The number of strawberries is 5 over 2, right? 5 over 2 is the same as 2.5 or 2.5. So 5 halves in, or that in could be on top. All 3 of these things are equal. 2.5 in, 5 halves in, and 5 in over 2. Okay? Hopefully this helps you, and if you do the retake, and I hope most of you do better. And each time you do something, each time you do a little work, you get a little better, a little stronger, a little smarter. Okay? All right.